Hello and welcome to another exam paper walkthrough. I'm going to be carrying on with my GCSE Maths Edexcel predicted topic papers today. And this paper is for paper 2/3F. And this is going to be what I call a very likely paper. I'll discuss what I mean exactly by that shortly. If you've not already done so, attached to the description to this video, you'll find a link to a Google Drive where you can download a copy of the paper. I'd strongly recommend you either attempted the paper before watching the video or do it alongside the video just to get the most out of the questions. I'd also recommend a bit of music on in the background. I always like doing math papers with a bit of music on. Um, and like I said, this is in preparation for the June 25 examination series. I've taken I've taken the topic lists for this from First Class Maths. If you've not already checked out First Class Maths resources, I'd strongly recommend you do. They've got a fantastic bank of papers and topics that you can dive into. If you find this video useful, please do subscribe if you like. If you do that and turn notifications on, as soon as I release any paper predicted material for paper 3, you'll get a notification. Right, what do I mean by very likely? First Class Maths revision list for Edexcel looks kind of like this. There's also the 2-star and the 1-star topics. What I've done is I've created this what I'm calling a very likely paper based on their 5-star and 4-star topics. I've also produced a good chance paper, which I would recommend giving a try if you've got time. The good chance paper is just based around the 3-star topics. So that's why I would say that there's a good chance that they'll be on there, but not certain. They're very likely. Again, there's no certainty. There just isn't, I'm afraid. It's just based on analysis. Those are the most likely topics. Right, let's get into the paper. Okay, question 1. Write these numbers in order of size, starting with the smallest. So the smallest value here is -7. So we've got -7. Followed by next smallest, -4, followed by next smallest, -2, followed by 1, then 8. Separate them with commas, and there we go. Question 2. Tony goes into a cafe and buys 2 cups of coffee and a piece of cake. Each cup of coffee costs £2.75. Each cake costs £2.90. Tony pays with a £10 note. He thinks he will get more than £1.50 change. Is Tony correct? You must show how you got your answer. Right, so 2 cups of coffee is going to be 2 times by £2.75, and a piece of cake, so plus £2.90. In effect, we can, no, we won't. So I'm going to add these up first of all. So 2 times by £2.75. Plus £2.90 gives me a total of £8.40. So if you pay us with a £10 note, I'm going to do 10 minus £8.40, which is going to give me, 10 minus my last answer gives me £1.60 change. So he thinks he will get more than £1.50 change. Is Tony correct? Yes. He gets £1.60 change. Question 3. Simplify a times b times 4. So that's just going to become 4ab. Simplify. So we're collecting like terms. So we've got 4x minus 1x will give us 3x. And then we've got plus 3 plus 5 gives us plus 8. Question 4. The box below contains 3 mathematical symbols: equals, less than, greater than. From the box, choose a symbol to make each of the following statements true. So 5/8 is greater than 2/7. And then minus 2 times minus 3, that would give you -6. And then would give you +6, and then -3 plus 9 would also give you 6, so those two are equal. Question 5. Here are the first 4 terms of a number sequence. Explain how to work out the next number in the sequence. So we are so the difference from there to there is 6. The difference from there to there is 6. The difference from there to there is 6, but it's minus 6. So we subtract 6 each time. Work out the next number. We do 79 minus 6, which would be equal to 73. Part B, work out the difference between the 5th and the 7th term in the sequence. So technically speaking, we don't really need to work out the difference would be, so if we've got 5th, 6th, 7th, if the difference between each term is 6, the difference between these two terms would be 12. Explain why 52 is not a number in the sequence. So we could carry on this sequence until we got to 50 and see whether 52 was in there. Alternatively, we can say that this sequence is minus 6n, and then to minus 6 we would need to add on 103. And can that be equal to 52? So if I take these over to the opposite sides, that would be 51 is equal to 6n. So n would be equal to 51 divided by 6, and with 5, n would need to be an integer. N would need to be an integer. Right, question 6. Change 5,000 milliliters into liters. So there were 1,000, so 1 liter is equal to 1,000 milliliters. So 5,000 milliliters is going to be equal to 5 liters. Right, question 7. Write down the ratio of 45 grams to 15 grams. So 450 grams to 15 grams. If we divide both these by 15, that would be, in its simplest form, 45 divided by 15 is going to be 3, so that would be 30. So that would be 30 to 1. Right, question 8. Natasha is thinking of a number. She says, my number is odd. It is a factor of 36 and a multiple of 3. There are 2 possible numbers that Natasha can be thinking of. Write down these 2 numbers. So I'm going to look at 36. So my factor pairs of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So which of these numbers are multiples of 3 and odd? So we've got that as a possibility, that's not odd, and that. So we're looking at 3 and 9. Question 9. Carol goes on holiday to South Africa. Carol wants to change £850 into South African Rand. She wants to get as many 200 Rand notes as possible. The exchange rate is £1 is equal to 18.53 Rand. Work out the greatest number of 200 Rand notes Carol can get with £850. Right, so we're going to say then, so if £1 is, well, go for a non-count version. So I'm going to do 850 times by 18.53, and then I want to divide my answer by 200, and then I'm going to kind of truncate the number. That means chop off the decimals. So 850, we'll do it as a fraction, 850 times by 18.53 divided by 200 gives us 78.7525, so we can get 75 £200 notes, 200 Rand notes. Right, solve. So this is a nice solve in that I could expand the brackets, or as a shortcut, my first step could be divide by 4, which I always like to do where I can. X minus 6 is going to be equal to 11. Add 6 to both sides. X is going to be equal to 17. There are only red beads and green beads in a bag. The number of red beads, the number of green beads is 1 to 4. There are 35 red beads in the bag. Work out the total number of beads in the bag. Okay, so that means that there are 5 parts. So each part is going to be worth... Oh, no, sorry. So red beads. So if we've got red to green in a ratio, we'll use that 5 in a moment anyway. 1 to 4. If we've got 35 red beads, it means each part is worth 5. So 35, sorry, each part is worth 35. So if we do 35 times by 5, we'll get our total number of beads. So 175. Question 12. Change 1,756 grams into kilograms. So there are 1,000 grams in a kilogram, so that would be 1.756. Question 13. Peter, Bruce and T'Challa share £600 between them. Peter gets 2/5 of the 600. Bruce gets 1/4 of the money that is left over. T'Challa gets the rest of the money. T'Challa says, I would have got more money if we'd have shared the £600 equally between us. Here's T'Challa right. You must show how you got your answer. Right. So if we say that if Peter gets 2/5, then what's left over is 3/5. So if we do 3/5 times by 600, and then T'Challa gets 3/4 of what's left over. So if we times that by 3/4 afterwards, that'll give us our total that T'Challa gets. So 3/5 times by 600 times by 3/4 gives us £270. If we'd have just split it equally, 600 divided by 3 is equal to 200. So is he right? No. No, as £270 is greater than £200. Right, question 14. The probability that a new fridge has a fault is 0.015. What is the probability that the new fridge does not have a fault? That would be 1 minus 0.015, which is going to be 0.985. Right, question 15. In a bag, there are only red counters, blue counters, green counters, and yellow counters only. So we've got 4 types of counters. A counter is taken at random from the bag. The table shows the probability of getting a red counter or a yellow counter. The number of blue counters to the number of red counters is 3 to 4. Complete the table. Okay, so far we've got 0.4 plus 0.65. Plus 0.25 is equal to 0.65, which means that the remaining probabilities have to cover 0.35. And if we've got this as our ratio, then it means that the fraction of blue counters to start with is going to be 3 out of 7. So if we do 3 out of 7 times by 0.35, so 3/7 times by 0.35 gives us 0.15 for blue. And then if we do the opposite version, 0.15, well, we can actually say that the remaining probability must be 0.2 then. If I show the sum there, 0.35 minus 0.15 is going to be equal to 0.2. Right, question 16. An exam paper has two papers, a paper 1 and a paper 2. Paper 1 has 60 marks, paper 2 has 90 marks. The pass mark is 2/3 of the total number of marks. Wanda gets 70% of the marks on paper 1. How many of the marks for paper 2 must Wanda get in order to pass the exam? Right, so we want 70% of 60, so that would be 60 times by 0.7. So that will tell us the number of marks that she gets on the first paper, which is going to be 42 marks. Right, in total, if she needs 2/3 of, so we'll now do 60 plus 90. That's the total number of marks times by 2/3. Will give us the number of marks that she needs. So that's going to be 150 times by 2/3, which is going to be, I think, 100. Yep. So the number of marks that she needs to get is going to be 100 minus 42. It's going to be 58 marks. Just double check. It doesn't say what percent that she needs. It just says how many marks. So 58. Question 17. Steve bakes 420 cakes. He bakes only vanilla, banana, lemon, and chocolate. 2/7 of the cakes are vanilla, 35% of the cakes are banana. The ratio of the number of lemon cakes to the number of chocolate cake is 4/5. Okay, so if we say vanilla, banana, lemon, and chocolate, and we'll do some sums. Right, I'm going to start with 2/7 times by 420. It's going to be equal to 7 divided by 420 is going to be 60, so that's going to be 120. No, it's not. I think it is actually. 2/7 times by 420 is 120, yeah. 120 vanilla cakes. 35% of them are banana, so if I do 0.35, that's 35 as a multiplier, times by 420, that's going to give me 420 times by 0.35 gives me 147 banana. 147. So that means that in total we've accounted for 267 cakes, which means that we've not accounted for 420, sorry, 420 minus my last answer. We've not accounted for 153 of the cakes. And then if we've got the ratio of 4 to 5 for that, that means that we've got 9 parts. Sorry, we've got 4 to 5 means that we've got 9 parts left to share between that 153. So if I do 153 divided by 9 and then times by 4, that'll give me the number of lemons. So divided by 7, divided by 9, and then times by 4 gives me 68 lemon cakes. Question 18. Last year, the cost of a season ticket for a football club was £560. This year, the cost of the season ticket has increased to 600%. Write down the increase in the cost of a season ticket as a fraction of last year's cost. So the increase in cost is going to be the difference in price divided by as a fraction over last year's cost. So that's going to be over 560. So that's going to be 40 over 560. And then we can calculate that down using our calculator. 1 over 14. Question 20. A square has an area of 81 centimeters squared. Find the perimeter of the square. So if I call it x for now. X squared is equal to 81. So we're going to say that x is the square root of 81, the positive square root of 81. So that would be 9. Arguably, you could have minus 9, but as we talk about a length, we can't really. And then the perimeter is going to be 4x. So the perimeter is going to be equal to 4 times 9, which will give us 36. The diagram shows a right angle triangle and a parallelogram. The area of the parallelogram is 5 times the area of the triangle. The perpendicular height of the parallelogram is h. Find the value of h. Okay, so the area of the parallelogram is going to be equal to the base times by the height. So that's going to be 30h. The area of the triangle is going to be equal to a half of 16 times 9, which is going to be 8 times 9, which would be 72. The area of the parallelogram is 5 times the area of the triangle. So we could times this by 5, or we can divide this by 5. I'm going to divide that by 5 because that's a nice easy number to divide by 5 is equal to 72. So 6 lots of the height is going to be equal to 72. So the height is going to be equal to 12. Right, question 20. Here are the first 4 terms of an arithmetic sequence. Write down an expression for the nth term. So we've got a common difference here of 6, which means that my sequence must start with a 6n. And then we talk about what do we need to do to 6 to get to the first term. We would need to subtract 1. Question 21. Describe fully the single transformation that maps A onto B. So that is a reflection. In the line. Now I always like to give it as an equation, so that would be the line y is equal to 0. But you could state in the x-axis. Question 22. Write the number 0.0007547 in standard form. In standard form, we're creating a number. We place the decimal point somewhere to make it a number between 1 and 10. In this case, between the 7 and the 5. So it's going to become 7.547 times by 10 to the... And then technically what we do is we track the number of decimal points we've moved to make that slightly easier for ourselves. What we can actually view it as is how many zeros there are at the start. So 1, 2, 3, 4. So that's going to be to the minus... 1, 2, 3, 4, 5. So that's going to be to the minus 5. For part B, write 3.42 times 10 to the 4 as an ordinary number. So this 3 is now going to become 3 with 4 zeros or in that position. So we're looking at 3, 4, 2. That's 2 of the places. We're going to add 2 more zeros. Part C, workout. I'm going to use my calculator for this because we can do this just by typing it into our calculator. So if I type in a fraction, and I'll put these in brackets just to make things a bit more straightforward. So that's my first number in standard form times by my second number in standard form. But before I press equals, I'm going to make a rough estimate of the answer. So that should be typed in correctly. I'm just double checking my numbers. Right, if we think about, let's say roughly 2 times by 3 is 14, divided by 5 is roughly 3. That would become 7. So I'm roughly looking at 3 times 10 to the 15, I think. Yeah, there we go. So 3.082 times 10 to the 15. it in properly. 3.082 times 10 to the 15. Right, question 23. Stephen was driving to a hotel. He looked at his sat nav at 1:30, time 1:30, distance to destination 65 miles. Uh, Stephen arrived at the hotel at 14:48. Work out his average speed of the car from 3:30 to 13:30 to 14:48. You must show all your working. The first thing I want to do is look at the time difference between these two times. So that's 1 hour and a difference of 18 minutes. Right, we want our answer in miles per hour, so I want these as a fraction of an hour. So it would be 1 and 18 over 60, because there are 60 minutes in an hour, hours. My calculator would tidy that up, or we could tidy it up. We could say 6 is going to both those numbers, so that would be 3 over 20, but I'm not going to bother really with that. Right, so the only thing left then is speed is equal to distance divided by time. So the distance here is 65, and the time is 1 and 18/60ths. And then my calculator will do all the work for this. So 65 over, and I want to type in a mixed fraction. That's shift and then the fraction key. 1, and I don't even need to have tidied this up. My calculator will handle it. So that gives me 50. So my speed is 50 miles per hour. Right, question 24. Reflect shape P in the line y is equal to 3. So I always find it useful to draw the line first of all. So this is the line y is equal to 3. And then if I'm going point to point, that point would go to there, that point would go to there, and that point would go to there. And then join it up with as straight lines as we can. There we go. Right, question 25. Rotate shape T 180 degrees about the origin and label the new trapezium A. So 180 degrees about the origin, so that's that point there. If I take a specific point, so that point is going to go to there. That point is going to go to there. That point is going to go to there. And then finally, this point is going to go to here. So join up my points. Label it T. Part B, translate trapezium T by a scale factor of, oh no, we were told to label it trapezium A. So translate trapezium T by a vector of -1, so that's 1 to the left, and -3, that's 3 down. Label the new trapezium B. So if I take a specific point, I'll change pen for this. If I take a specific point, this specific point needs to go 1 to the left and 3 down. So that point would go to there, and then we can just trace the shape out. Translation, and label that B. Question 26. Here is a shape made from a rectangle and a triangle. The shape has exactly one line of symmetry. That's a useful point, because that means that if it's one line of symmetry, this side would also be W, and this would be 3.8. It's more, this is the key part. The area of the rectangle is 3 times the area of the triangle. So if we call that A, 3 times A. The width of the rectangle is W. Work out the value of W. You must show all your working. Okay, so the first thing I'm going to do is work out the area of the triangle. So the area of the triangle is going to be equal to half of the base, which we can't jump straight to. We've got to use this line of symmetry fact. So 3.8, 3.8 there. So I'll put the length of the base, which is 14, minus 2 lots of 3.8. And we want to times that by the height of the triangle, which is 6. Do that. So I'll type 0.5 just because I'm a bit lazy. 14 minus 2 lots of 3.8. I want to times that by 6. So that's going to give me 19.2 centimeters squared. Right, so the area of the rectangle is W times 14. So I'm going to go 14W is going to be equal to 19.2 times by 3. So W is going to be equal to 19.2 times by 3 divided by 14. So times that by 3 and then divide our answer by 14. Gives us... I've made a tiny mistake here. I shouldn't have been timesing it by 3. I should have been timesing it by 3.5. So if I go back to that, so I want to times that by 3.5 and then divide it by 14. So 4.8. So W is equal to 4.8. Right, question 27. There are men and women at a meeting. There are 28 women. 30% of the people at the meeting are men. Work out the total number of people at the meeting. Okay, so let's go for men and women. We're told that there are 28 women at the meeting, and we're told that 30% of the meeting attendants are men, which means that 70% must be women. So if I'll do it like this, 70% of the number of people at the meeting is equal to 28. That means that 10% would be equal to divide by 7, 4. So 100% would be 40. Question 28. Write 3,530 correct 2 significant figures. So that 5 is our second significant figure. So we're looking at 2500. Correct to 1 significant figure. 0 can't be our first significant figure. So that's our first significant figure. The number behind it is bigger than 5. So we would round that up. So we're looking at 0.09. Right, question 29. Write the ratio 4.5 to 2.25 in the form n to 1. Right, so if we wanted to get from there to 1, we'd be dividing by 2.25. So we do that there, and that's actually quite a nice one. Because 2.25 is exactly half of that, so that would be 2. So 2 to 1. Right, question 30. Gamora runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Peter 45 minutes to run the same total distance that Gamora runs. Work out Peter's average speed, giving your answer in miles per hour. So we're going to work out, if we start with Gamora, so 15 minutes at a speed of 16 miles an hour. Well, 15 minutes is a quarter of an hour. So in a quarter of an hour, she runs 6 miles. Sorry, no. She's running at a speed of, in 1 mile, in 1 hour, she would run 6 miles. So we want to work out in a quarter of a mile, she would run 3/2 of a mile. So 1.5 miles. If we then look at in 1 hour, she would run 9 miles. So we want to do 40, which is 2/3 of an hour. So if we divide that by 3 and then times it by 2, that would be 6. So that gives us our total distance. That would be 6 plus 1.5, so that would be 7.5 miles. We could do that as a sum. We could have said that 6 times by a quarter, just a nice check, plus 9 times by 2/3 gives us 7.5. Right, so Peter runs the same total distance that Gamora runs work out Peter's average speed. So speed again is equal, we'll say P. Speed is equal to distance divided by time. And we want his speed in miles per hour. So the distance is 7.5 and the time is 45 minutes, which would be 3/4 of an hour. And we can use, we can divide by a quarter, times by 4 divided by 3. But we can type it in like that on a calculator paper. So 7.5 divided by, actually 7.5 divided by 0.75 would be 10. So I'm going to say it's 10, but we'll do the sum anyway. 3/4. His speed would be 10 miles per hour. Right, question 31. Nick invests £200,000 in a savings account for 4 years. The account pays compound interest of 1.5% per annum. Calculate Nick's total interest. Calculate the total sum of interest Nick will get at the end of the 4 years. So we don't want the total in the account, we want the total interest. Right. So compound interest rate of 1.5 would be a multiplier of 1.015 because we want 100% plus the 1.5. So we want 101.5, which is the decimal is 1.015. So the total is going to be equal to 200,000 by 1.015 to the power of the number of years, so to the power of 4. So just double checking, I got 5 zeros there. Times by 1.015 to the power of 4. So that gives us 212.7101. So the difference would be interest. So we're not after the total, we're just after the interest. And it's going to be equal to, all we need to do is knock a 1 off there really. So 12272.7, and we'll go 71. Well, actually we'll go 01, but then when we give our answer, we'll go 12272.71. Right, question 32. Table gives information about the times taken in seconds by 18 students to run a race. Work out an estimate for the mean time. Give your answer correct to one significant figure. Right, so for this, we need to be looking at the sum of all of these times. The first thing we need to do is look at the midpoints. So each of these will have a middle value, which we're going to use for the estimate of the mean. So the middle of these two groups is 7.5, and we'll times that by 1. Middle of this one is going to be 12.5, which we'll times by 1. Middle of that will be 17.5 times by 1. Times by 7. And then finally 22.5 times by 8. And we're going to add these up, and we're just going to give this value here. I'll do it as a single sum, so 7.5 just times by 1 plus 12.5 times by 2 plus 17.5 times by 7 plus 22.5 times by 8. Hoping that we've typed that in fully correct, we get the value of 335. So our mean is going to be equal to 335 divided by 18. So divide that by 18, and that gives us 18.61 reoccurring. So if we're giving it to 3 significant figures, that's going to be 18.6. Right, question 33. So Stan wants to increase 150 by 3%. He writes down 150 times by 1.3 is equal to 195. Stan's method is wrong. Explain why. Well, 3% would be a multiplier of 1.03. So he's and I'll put that. Uh, he should have written 150 times by 1.03. Or we could say that method finds 30%. Right, Peggy wants to decrease 150 by 3%. Complete the statement to show how, I should say Peggy, can decrease 150 by 3%. So for that, we're going to be doing 100, so 3% would be 100% minus 3%, which would equal 0.97. So she should do 150 times by 0.97, which would be equal 150 times by 0.97 gives us 145.5. Right, question 34. It takes 14 hours for 5 identical pumps to fill a water tank. How many hours would it take for 4 of these pumps to fill another water tank of the same size? So if we think we've got 5 identical pumps and it takes them 14 hours, so that the number of worked hours then is going to be 5 times by 14, which would be 70 worked hours. So that means it would take one machine 70 hours. If we want 4, we're going to be doing 70 divided by 4, which would be 17.5, I think. So 70 divided by 4 gives us 17.5. Right, question 35. Describe fully the single transformation that maps S onto T. So we're going that way. The orientation hasn't changed, so it must be a translation. So it's a translation. And we could describe it in words. We could say that it's moved a certain amount to the left and a certain amount up, or we can write it as a vector. So if we pick a like point, we'll go this corner and this corner. So to get from there to there, we're going 2, 4, 5 to the left, so that would be minus 5, and then 2, 4, 6 up, so that would be our full transformation. Question 36. The table shows information about the dress sizes of 25 women. Find the median dress size. So if we've got 25 women, the position of the median would be 25 plus 1 divided by 2. So that would be 26 divided by 2, so that we would need the 13th value. So the 13th value would, it's not, if we keep a running total, so we've got 2 that are an 8 or smaller, we've got 11 that are a 10 or smaller, and then we've got 19 that are a 12 or smaller, which means that the 13th value, well, the 11th is a 9, is a 10, the 12th is a 12, 13th is a 12, so it would be a 12. Right, 3 of the 25 women have a shoe size of 7. Mia says that if you choose at random one of the 25, sorry, May says if you choose at random one of the 25 women, the probability that she has either a shoe size of 7 or a dress size of 14 is 9 over 25, because 3 over 25 plus 6 over 25 is equal to 9 over 25. Is May correct? You must give a reason for your answer. That would be true if we assumed that none of the women could be a shoe size of 7 and a dress size of 14. So is May correct? No. Some women would be size 14 and size 7. shoe size 7. Right, question 37. There are only blue pens, green pens, red pens in a box. The ratio of the number of blue pens to the number of green pens is 2 to 5. The ratio of the number of green pens to red pens is 4 to 1. There are less than 100 pens in the box. What is the greatest possible number of red pens in the box? Okay, if we start putting some of this information in, so if we say B to G to R, I feel like I've missed a letter out there. Red, sorry, blue, green, red. No, there were only 3. So the ratio of the number of blue to green, so blue to green is 2 to 5. The ratio of the number of green pens to red pens, green pens to red pens is 4 to 1. So we're going to combine these ratios, and it's the green one that kind of determines how we combine them. So the lowest common multiple of 5 and 4 is 20. So if we make these all equivalent fractions where the green part is 20, we can combine them. So to get from there to there, so 5 to 20, we times by 4, so that must become an 8. And then to get from there to there, we times it by 5, so that would be 5. So that's our simplified ratio for all 3 parts. And we're saying that that number has to be less than 100. So if we look at how many parts that we've got to start with, we've got 8 to 20 to 5. That means that there are 33 parts. So if we do 100 divided by 33, that would be assuming that there are 100, but that will give us a decimal value. So that will give us 3.03 reoccurring. So there can be a maximum of 3 sets of the ratio. We only want the greatest possible of red, so that's this part here. So we're going to do 3 times by 15, times by 5 equals 15. So there can be a maximum of 15 red pens. Okay, and that brings us to the end of the paper. So before I sign off, I'll just bring up the topics that each of these questions were on and sort of a rough grade boundary from past students. Okay, this is the topics that have been covered. So the skills tested are over here. This is the maximum score for each of them. There's a slight difference between the maximum score and the maximum score for the paper. The reason for that is there are a couple of parts that I missed off. So like a part C or a part A that didn't really hit in the skills that I wanted to test. So they're just kind of a few extra little marks. The rough grade boundaries, so out of all of the students that sat these papers originally, they've kind of done some number analysis, and that gives you a rough idea of the grade boundaries for this paper. So when I was using the the 5 and the 4-star topic list, these are the topics that I selected. I then arranged them by mean percentage, just to make sure that the paper built in difficulty. So we got a nice kind of similar-ish kind of style to the paper as you will sit for your exam. I used their website to generate the questions. Hope you found that useful. If you have found it useful, I'll say it again, please do subscribe if you like and turn notifications on, and you'll get notified as soon as any of my other revision material hits. Also, should be a playlist appearing now. Check out the Good Chance paper as well. That would be a great form of revision. Other than that, thank you very much for your time in watching the video, and good luck with your exams.